Yes. No offense meant. And by the way, my apologies if your eyes get really painful because I'm not that good at PowerPoint, so I shouldn't get any recommendations from that little icon there. Anyway, I have lately seen a lot of talks with titles like protecting your server using Docker containers, using Dockers to analyze vulnerabilities, analyzing malware using Dockers, and doing whatever in security, doing Docker. This is purely fictional. Okay, I haven't taken these titles from anyone. No offense meant. I don't want to overlap with any other talk, but let me warn you about something. This is my face when I go to those talks. So in a normal environment, in order to get persistence, let's say that you got access to the system. I don't know which one, because well, you go to an Apache system, or you got to a graph database, whatever. You got access to a system. You usually need an exploit in order to raise your privilege. And once you have higher privileges in the virtual machine, you can start attacking the drivers. When you start attacking the drivers, you go outside of the virtual machine. And unless the administrator is a dumb ass, the virtual machine will run as a user. So you need an additional exploit to become root in the main server. Okay? That's usually $3 if you do the mathematics. Well, 0 days and whatever it took to get in. But if you use Docker, it's just one bug in the kernel that you need. The main difference between having Docker and not having Docker when someone is raising privileges is none. Okay? No difference whatsoever. The kernel is exactly the same one. Not even this guy would like this. That's a Spanish joke, completely untranslatable. Using Docker for the right things, but don't use it as a security container, please. That's a tip from me, a piece of advice. I had to say this, okay? So the real disclaimer, well, this is what it says. In case you didn't know, this talk is about a bug bounty from Shopify. Shopify is the largest outsourcing platform for online shops. Instead of setting up your own server, you go to their website, and from their website, from Shopify, you set up your own shop, and they do everything except for shipment. I think it is the largest company of its kind in the world in terms of sales. So I don't want to pick on them or show any disrespect. In fact, people working for Shopify have always been very professional. They've always been very dependable, and I fully support and endorse them in the way they do bug bounties, the prices they paid. If they want the best auditors out there for their products, well, obviously you need to make the best possible offers. People will not stop doing something else or work in another area to do a bounty for 1,000 euros. If you really want the best people to turn around and look into your stuff, you really need to offer a good compensation. But obviously, last sentence, nothing in this world is perfect. And the same applies to this. So, what's all this about? Well, it all started one day when someone came to the Radar channel, placed a link there and said, could you please have a look at this? We've opened a new bug bounty. If you would take a look at this and tell us. The thing is that we did take a look. We mentioned this with several friends. As it happened, one of our friends was actually working on the security side for Shopify, and we asked him about the guy that plays the bug bounty. So we opened it. If you want to do so, go ahead. That's what they told us. So in a month from that date, we saw this in Twitter. I don't know if you use Twitter a lot. They splashed out quite a large amount of money in just one day. Out of that money, a quarter went to a colleague of mine and myself. we make them bleed to death.
Describe más.
This is a description of bug bounty in open source. You always lose. The target in this case, well, no, this is going to be a bit strange. This was an embedded Ruby interpreter that was inside another Ruby interpreter. I know it sounds strange, and I know that you will be confused, but basically you have an interpreter called mRuby, which is a light interpreter. Instead of the official implementation of Ruby, which is very heavy, this is a much lighter interpreter, which is part of Ruby through a plugin, or a gem, as they call it in that environment. They call it gem. What this small virtual machine for Ruby does is that it gets loaded as a sandbox, okay? Within Ruby, you do a gem, you load this small interpreter, limiting access to the file system and many other things. This they use to execute in an isolated way from the normal environment. I think the normal environment works on Ruby Rails, and most of the web environment works on Ruby Rails. In order for the scripts from customers to run safely, you need to ensure that those scripts are executed away from the main platform so that they cannot be hacked. And that's the reason why they came around with this little invention. So a very rudimentary chart of this. So this is a graphical description. So all of this would be one process. So the normal Ruby interpreter that you would have, that interpreter would load a library called mRuby engine gem, which is the plugin they did. Inside the library, you have the small interpreter, the light interpreter. The idea is that whatever you execute in here, I always do the same, I'm sorry about that. Whatever you execute here cannot go all the way outside into the memory, okay? It's like a sandbox. So one of the things that they implemented, obviously with limits to memory usage, so you cannot execute large scripts consuming resources. There is a limit on execution time, 100 milliseconds off the top of my head. There's also a limit on the number of instructions, and so on and so forth. Apart from the fact that this interpreter is compiled without most of the libraries, it has no access to the file system, no access to the network, and not able to include new files. This is an example of what the core gems would be. This is what gets loaded. Okay, numbering, strings, arrays, hashes or lists. This proc, which is safe. So it just leaves the basics. This would be an example of the script for that sandbox, a normal Ruby script, where you would include the mRuby gem, which is what they compiled. Here you have the global for 1 megabyte, the maximum memory, 4 megabytes for execution, maximum 100,000 instructions, and 100 milliseconds. So they initialize the engine with these values defined here, and then it is just a call to the sandbox with the script that was passed through stdin. So it is a Ruby script executing something else inside an mRuby interpreter. So this would be the layout for payments. By taking a look at this, where we were not looking for logical problems or auditing, so these ones we got rid of. This we got rid as well. So we focused on the two at the top, the two most interesting ones and the ones requiring the least effort. The one for 20,000 I will rule out, but anyway. So let's go for it. What we decided to do, well, this is a very old joke anyway, but it is a very good description. an investigator comes along and says, I put together a tool that analyzes the binary and then uses an SMT solver. So I found a bug in 3 days. The other has found 3 bugs in 1 day, but I'm not a new. Yeah, footers may be shit, but they do work. They work perfectly well today. This is the process. You usually sit down, study the case, and set up everything. You let the fusser do its job. You play Battlefield, you use your PlayStation, you go for a beer, whatever. And the last thing is profit. So far so good. That was the talk. Questions? So, the standard process is this one. You try and collect a number of samples. That makes sense. You do corpus distillation, you do fuss, you do triage, you do debugging for hours until your eyes are painful, and then you do profit. So everything is very simple, even when you have no idea about exploiting or security. Fussing nowadays, with AFL and many other fuzzers, it is just about executing it, even without samples. Anyone can do it. The problem is about debugging. So the only thing we changed in that outline is the 2 additional sections: generating a dictionary, number 3, and number 4, writing a wrapper for the module. Why a dictionary? Well, fuzzers are usually very efficient, mutating binary data and generating different samples from a binary file, but they're not so good when they have to deal with languages. In this case, we wanted to do fuzzing with a language. These are words, not binary code. So our best option was to create a dictionary. One of the options, the easiest way ahead, is to extract the raw data section and extract all the strings from there. The problem here is that everything will be mixed up. We will have all the error messages in the program. We will have anything else which is not part of the language. So it's very quick, but it has a lot of noise, and then there will be mutation of samples and words, consuming CPU, something that is not useful to find bugs. But we can do it with just one command using Radare. So it takes the binary, it analyzes it, it gives you the strings that are in whatever section you're interested in. This is the normal output, in fact. Here it tells you what section it found the string in. These are the strings that it found. If you want, you can pass it to JSON if you add dash JSON with any other program. So in this case, instead of doing this, since it's open source, we had to define methods, classes, functions for the interpreter. If you take a look at the code, it always uses, you see that it always uses that type of definitions. With just a grep command, it gives you everything here. It gives you all the words. So with a little bit of grep and scripting, you create a dictionary. How does it create a dictionary? Well, with the basic words. I don't know if the time class would be there. Another very important thing when fuzzing is sanitizing everything. This has made life so much easier for developers and bug hunters alike. There's all sorts of sanitizers out there. This is a compiling time instrument. I cannot give you a technical talk about fuzzing because I don't have the time, but anyway. So sanitizers. In order to compile with sanitizers, the ones at the top imply modifying a file, well, because that's the way Ruby works. I don't care about Ruby that much anyway. That's something we need to do. And then you have to create a wrapper. That was section 4. A fuzzer needs to instrument the code to the fork server for performance reasons, things that I don't want to mention now.
I don't want to go into too many technicalities because I just don't have the time for it. So we had several options. First of all, to instrument the main Ruby interpreter plus the module, then to instrument only the parser without the module. And it was not good because I said, well, this doesn't work when the parser goes into my sandbox. So sometimes the execution time is over, the sandbox stops it. And the last thing that we did was just to create a mini program so that it loads the Ruby. So 85 lines. We initialize the engine, allocate the engine in the memory pool. We read the script, pass the code, and execute the code. So it also requires 2 more hacks because the Ruby machine was not virtualized. So a couple of hacks more, and that was it. It was very simple. So this is an example, 85 lines, not very complicated. And just in case you want to find out more, this is an example of the files that Fuzzer creates. On the left, we see some rubbish, but if you clean it, and then you start pointing, you see variable equals this and that. So this is like hell. So it doesn't. It looks senseless, and actually, yes, there is no sense to it. And the one on the right is more makes more sense. Then you have to do triage, because if you have like 10,000 crashes, of course you cannot go through them all. So you need a way to quickly classify them and to select the most important ones. To do that, we may use sanitizers. Whenever there is a bug, often an alert is triggered. It tells you the type of it, whether it is overflow, you name it. And we may make a preliminary classification, all that with 78 lines. Well, it is not very nice, but it works. Well, for kernel, I do it in a different way. I upload it in a different database, but this time I was in a hurry. And then I just did this to see if it worked. This is an example. So those of you who love WAK, please do not kill me. So here, classification type, bug, sanitizer, and then the name of the function, if there is a function. Results after 2 weeks of fuzzing, so 12,000 crashes, and 49 of them were unique 2 weeks of fuzzing. So I classified with base script in folders. So crashes, and then the direction and the address and the name of the function. And well, in the meantime, Shopify, imagine it like that. Well, we did a bug bounty for a small amount of money, but everything is fine. Results. We just didn't have lots of time. I could only send out 6. I had 50. Another colleague had more than that. I could only send out 6. And this is the result. And Montoro, our Minister for Treasury, loves that. So, well, we pay, they steal from us. And after that, well, there was a bit of a buzz in Twitter. I don't know whether you follow that on Twitter. So there was a bit of debate there. Those of HackerOne were very proud of giving us so much money, of breaking records. However, the other people say, what are you doing? Our code is so awesome. So let's shower some free money if anyone finds bugs here. Free venture capital money, I get from Shopify. This is crazy, 10,000 euros or Fortnite. Why auditing now? Let's do a bug bounty. Let us do them. Let's do the monkeys. Do that. So I'm going to show you some theories about Shopify. Richard says, I think Shopify was not expecting this. Anyway, congratulations to those who did it. Another girl, she's on Bootcrowd, I think. I don't know whether to say that this is a success or a failure. And Yannick, they needed to burn some budget, and Charlie Miller says, if I were to call it a success, I would say that it is a very expensive success. After that, I decided to update and say, let us insert the sandbox in another sandbox, and let us then reduce the payment by 10%. But actually, the thing is that we didn't get the second sandbox, but anyway, the prices have been reduced by 10%. Therefore, they are not as interesting as they used to be. So this is the Shopify solution, putting the sandbox inside another sandbox. After this, even the CEO came out to Hacker News to give his version of his story. Well, he was showing off saying that sometimes they made more than $300,000 in days such as Black Friday. The thing is that the version of this mind was quite interesting. He was saying that because they are not as well known as those in Silicon Valley, they cannot attract as many people as companies in the Valley do. Well, if of course, because they are not paying that much for bug bounties, so they said that that is the reason that made them increase the prices. Well, first of all, they attract people, and later on, they reduce prices by 10%. He was talking about one-to-one business. So, well, yes, it was good. Yes, they managed to be on the news. They managed us to talk about them. But the thing, they tried to reverse that. Instead of saying, looking bad, they said that they knew that they were doing that on purpose and that it was very much aligned to the business model. And I just did not believe it. So 3 months later, I executed crashes, and there are still 26 crashes. More than half of the crashes that I found continue to be there. So I believe that lowering down the price was not as successful for them. So they continue to have 26 crashes, and some of them are new. That means that either they do not fix them rightly, or when they fix them, they open other code passes, and now I'm reaching to places that I couldn't access to places that I couldn't access before. And then I have a DevOps bonus. I don't know whether to keep it for tomorrow or to share it today. So we have people from DevOps now, and I'm going to share with you my viewpoints. I'm not from the box, and it is easier to give your opinion than to do it. Often people include fuzzing in their development process, then they order an independent audit, and then when you burn all the bugs, you do a bug bounty. To include fuzzer in your development process, libfuzzer is much better for that. A good example of it is ClusterFuzz by Google, more than 700 virtual machines. And if you have open source projects, the OS Fuzz project by Google, if your project is big enough, important enough, they fuzz you. They open the tickets. The only thing that you have to do is to upload the samples, and they deliver the infrastructure to you. They put OSS Fuzz available to you. This is an example of a friend from colleague. He often reports a lot to open source projects, and to the latest one, he just attaches an example of fuzzer with libfuzzer. So this is an example of the password. So the line that has what there is the alert is shown in different color, executions per second, the coverage code of that specific file, how many code has been examined through fuzzing, an example of a report for a crash. This is automatically created by their tool, and this is the process of OSS fuzz. You write down your fuzz, you configure it, Jenkins. Some people use it in GitHub. Jenkins gets your code and builds different fuzz every time. That is sent out to a loop of the Google loop, and then it opens up tickets automatically for you in the ticketing system. Then this is a case. Google Chrome uses ClusterFuzz, so it works with different components of the browser. From XML, they all work. So they have like 500 instances with sanitizer, 100 with memory sanitizer, and others with undefined buzzer. Again, passwords, I don't know whether you see it by components. So the buzzers of H.264, they show all that to you in a separate manner, the number of executions per second, number of crashes, number of new crashes, statistics in the last 30 days. Well, this information is not public, but once they posted this, and that's what they said. In 30 days, 120 fuzzers, 112 bugs filled, and they have executed 14 million tests. Analysis of the bugs found so far, different types of them, stagger, overflow, etc. This works because Chrome is one of the most difficult places to find a bug. And if you find the bug, you are very likely to be dead because the next day will be reported by someone else. Clusterfuss will get it. Unless you find, we are talking about logical failures, it's very difficult to find anything through fuzzing. Obviously, after that, you need to audit the code. Once you burn all the bugs, then you order a source code audit to an internal company. So often they do it in a week or a month, and you hire them for them to kill those logic bugs, only found by human beings. So that would be the ordinary process. Once you do that, then you do a bug bounty with Hackathon, Bookcrowd, Jogosha, which is the mother of this rootage, or you can publish it on your website and that's it. So this would be the most logical process. And last, I would like to thank Proyon. He works in Shopify, and also Francisco Alonso. He also works with me. He also did fuzzing, helped me with the fuzzing. So now I'm very happy to take any questions that you may have. So I hope that you found my presentation entertaining. So I'd like to remind you that this room is connected with room 19. So please now ask your questions. I guess that they're very hungry. So Jaime, please, we asked Jaime to repeat his presentation yesterday. We will make this experiment. We asked Jaime to do that for us because he's a very, very good friend. You know that if something goes wrong, none of us will be impacted. So meaning that if there is no audience or whatever. So he will give the same presentation, and I want to go back through the two videos because I want to compare them. I will compare both videos of both presentations. Do you encourage people to make bug bounties? But do you do it for money? Not for entertainment? Well, I don't do it for the sake of doing it. I don't often do them, but if the opportunity is there and it is interesting, and then you guys say, well, this is not very difficult, yes, I do it. I'm not discouraging people to do it. I know many people who regularly doing it. You've mentioned Jogosa. People beyond security have a stand outside there looking for exploited reverser precisely for this type of things. So come to them, address them, and ask them more about that. Well, if there are no questions, now we break for lunch. Be back on time after lunch, please. Oh, sorry, I forgot to mention the following. We found the code. We left it.